This is code.org. Let's see what we're doing. Investigate and modify. Run the program. Don't gotta tell me twice. And let's see. All right, total checks 1. The middle value is 30. Okay. Oh, yeah, so this is index 0, 1, 2, 3, 4, 5. I guess the middle value would be between these, but that's fine. Total checks 2. The middle value is 50? So maybe it's only looking at this chunk. First set is 4. Oh, first location of 50. Okay, so it located our target value. All right. How many checks are done if target is the first item in the list? All right, let's give that a shot. 10. It should just be 1. Oh, interesting. 2 checks are still done. All right. Now, look at the binary search method in Java search.java. What do you notice about the code? What do the variables left and right represent? Add print statements at the beginning of the while loop to print the elements that are located at the indexes left and right. Okay, so at the beginning, left and right, and let's run. So first, left is 0 and right is 5. And so this is the indexes. We could also, I'm going to print the values as well. I want to print the values at these indexes. All right, so at first left is 0 and the value is 10, right is 5 and the value is 60. Keep in mind we're looking for the number 10 at this point. Total checks 1, where does that print? That's going to be printing right here. So this is the first check, yep. The middle value should be 30, which makes sense because it must be rounding it, or it must be floored. So the middle value is really, well, 0, 1, 2, 3, 4, 5. 5 divided by 2 would be 2.5. 0, yeah, and 2.5, it's going to be floored. So that just results in 2. Okay. Where what I mean by that is the decimal and anything after it is ignored. It does not round up. Okay, and then let's see, we have right 1 value is 20. Oh, so right moved all the way over to here. Left is still this. So it must be decreasing the scope, the area that we're looking at. In council, add the following. Oh, interesting. So what do I notice? Well, the second set, we're looking for 45. And let's see, first set. Then we start, left is 0, and that's 67. Right is 5, and that's 81. That's our first check happening. The middle value is 72. Yep. The left 0 value is 67. Right 1 value is 45. Oh, and so we've moved all the way over because 72 is greater than 45, or 67 because the middle value was greater than this value. Real quick, guys, what's going on is this. You pick the center number. The list has to be ordered, so it only works in a sorted list, right? This is sorted from least to greatest. You pick the center. If the center number is, let's say I'm looking for 27, if 27 is greater than 18, well, then I know I can throw out this half of the list. So I look at this number, I look at this number, divide by 2 and grab the middle index. 18 is less than 27. I am not going to look at this part of the list. Now I grab a new lowest number at index 5, a new highest number, which would still be at index 9, and look at the middle. 57 is greater than 27, so I throw out this half of the list and kapow. That is a binary search. That's what we're doing here as well. Cool. Complicated, we'll get it. Onward.